Oh, hi, good morning, everyone. Good afternoon, depending on where you are. First of all, I would like to thank Sarah Wolfalds for organizing this session with me. And hi, Sarah. She has the coolest glasses that you can find on the planet. And then I also want to thank Andy King and Sandeep Pillai for agreeing to present and share their wisdom in this session. We are going to tag team, as some of you know or some of you don't know. We have worked together in various ways in the past. And today we're going to tell you why p-hacking is okay, sort of, and how to do it better. And so I am going to kick off. Here's what's going to happen. I'm going to talk about abduction and inference to the best explanation. And then Andy's going to talk about mapping, which he's done a lot of so that you all don't get lost. And then Sandeep is going to talk about historical methods. And we're each going to take about 20 minutes or so with some leakage. And then we're going to open it up for questions because we have a series of questions, some of which we've prepared, but a series of questions like, what do we do with all of this? And I am going to take it away and kind of explain the problem. And there we go. So with no further ado, I'm going to try to share my screen successfully. I assume everybody can see that. and off we go. Okay, so I'm going to start with a little story because I like stories. And if you look, and you can find this, some of the worst predictions of all time. And here is Thomas Watson Sr. saying that I think there's a world market for maybe 5 computers. So we immediately see this as absurd. I think I have 3 computers on my desk as we speak, and 2 of which are functional, so that's good. And off we go. And there's a question. This is really a lovely prediction. And the question is, why do we like it? You can go search for world market for 5 computers, and you get 567 million results in about 1.01 seconds, which is quite a remarkable thing in and of itself. And there's the quote. I think there. And the question is, why do we like this story? This is a beautiful, beautiful story, which is attractive. And it's something you can tell over a beer. And it's actually quite compelling because it makes us feel good that, look, somebody who was an expert, the CEO of IBM, didn't get it. And then there's a second question. Does it matter if the story is true? Would you tell this story even if you knew it was not quite true? And so that's a second question that's of great interest. There's an ongoing chat. Okay. And so here's what he actually said. So speaking at IBM's annual stockholders meeting in 1953, this is the source of that statement. IBM had developed a paper plan for the IBM 701 electronic data processing machine. They didn't even call it a computer yet. And took this plan across the country to some 20 concerns that we thought could use such a machine. I would like to tell you that the machine runs for between $12,000 and $18,000 a month. Remember, this is 1953. This is an enormous sum of money. So it was not the type of thing that could be sold from place to place. But as a result of our trip, on which we expected to get orders for 5 machines, we came home with orders for 18. Okay, so I want to point some things out. He's speaking at the stockholders meeting, right? And he's talking about a very specific computer. And just in case you didn't know what it looks like, there's a picture of the 701. So I'm sure many of you have that in your corner office at your universities or wherever you happen to sit. So there you go. So what's the best explanation? You can now, with that richer information, come up with a series of explanations about what Watson actually believed. Maybe he did believe that there was a world market for 5 computers to eternity, which is implied by the initial quote. Maybe Watson's team underestimated demand for the IBM 701, which is also quite likely, but it isn't quite as lovely as an explanation. It's not quite as good because it's very specific. Maybe Watson was just trying to impress shareholders. And why would he try to impress shareholders? Well, it turns out, if you dig a little bit deeper, Watson was trying to get support for the cheaper 650. And so what better way to get support from his shareholders than to describe of this mistake and how surprised they were about the great demand for the 701. It's a good story. So maybe Watson himself was just telling a story, and it wasn't even that true. We don't know. But the question is, which explanation is most likely? And which explanation are we most likely to repeat, which makes it most lovely? And this is a great thing. And this sits at the heart of many tensions that we face. So there you go. There's the 650 in case you were curious. So when we judge explanations based on a series of attributes or virtues. So, and I'm going to go through each of these in part because they sit at the heart of inference to the best explanation. So we have methods to figure out if an explanation is likely. And the first one is coherence, which is, does this fit in with our prior thinking, our priors? And if something fits in with the way we know the world works, we will think of it as coherent. I like to tell my students, I give them a little puzzle and I say, I believe that parachutes are made from anti-gravity silk. And that is something that is conciliant. It explains the facts of a paratrooper falling slowly, but it's not coherent because we know that silk doesn't have anti-gravity materials. So that leads me to consilience, where consilience is how well something explains the facts. And we'll talk about how we think about that in the context of statistics in just a moment. On the lovely side, we have attributes that we like in our discourse. So we like things that fit with prior theory and contribute to prior theory, and that's coherence. But we also like explanations that are simple or parsimonious and use few parameters. And the reason we like that is not only because we have an attraction to simple explanations, but moreover, simple explanations tend to be more generalizable. They're more universal. And the reason is because if you have a parsimonious explanation, you have fewer assumptions in the story. And if you have fewer assumptions, then it's going to apply more generally. And the third kind of the final thing I'm going to think about a little bit is fruitfulness. How much does this particular explanation lead to future explanation? How good of it is a shoulder? Is it a strong shoulder that giants can stand on, so to speak? And that's what's fruitfulness. We value this directly, our fruitfulness, and we measure it by citations. So something that's particularly fruitful will generally be cited a lot. And we all know that citations are a good thing because we're academics. But notice the problem with this is there's no guarantee that what's lovely is also likely. A parsimonious explanation, Thomas Watson Jr. simply didn't understand computers, very parsimonious, very generalizable, that we don't have good knowledge of the future. But it may not actually be the true one. It may not be likely, but it's a great story. which is why you may have heard of that rumor before today. So here's a rough glossary, and I'm going to go over this again because these virtues are kind of hard to grasp. So the first is coherence, how well something coheres with prior theory, thinking, or common sense. The second one is consilience, how much it explains or reconciles many different facts. The third is parsimony. This is simple, uses few parameters. Some of you may have learned in your econometrics about an adjusted R squared, which explicitly penalizes the goodness of fit measure if it uses more parameters. That is an explicit appeal to parsimony. It's also in a lot of Bayesian statistics, but I don't know how familiar everybody is with Bayesian statistics. Generalizability or universality, few boundary conditions. Sometimes these are simple explanations. Sometimes these are referred to as basic knowledge. And fruitfulness, shoulders for giants and input into future ideas and understanding. So these are explanatory virtues, things that we value in an explanation. And what's really, really fascinating, while we pretend and we say that we're always on a search for truth and for the thing that is most likely and most conciliant and reconciles as many facts, in practice, we have a lot of incentives to find things that are parsimonious, generalizable, and fruitful. And these things don't always go together. For example, I don't know if Sandeep's going to use this example. If he is, I'm sorry, but I'm sure he'll go in much greater depth than I will. But you may all be familiar with the GM acquisition of Fisher Body. It sits at the heart of Ollie Williamson's work on transaction cost economics. And it is used as an example. And here's Klein et al. This is a source from 1978. This article has generated over 9,000 citations. It's a moving target. That is, I wish I had an article that was even close to 9,000 citations. I never will have. And here's Coase, no dummy. Here's Ramon, he's at HBS, and Danny Spulber, who's at Northwestern, right? He's at Northwestern, I believe. And Freeland, and they have 3 devastating pieces that point out that it is actually very unlikely that this was a holdup problem or a story of asset specificity, primarily because before the GM acquisition of Fisher Body in 1926, GM already owned a controlling stake in Fisher Body. And so if you look at, but these 3 articles together have only generated 600 citations. And the reason is because the real explanations are not nearly as parsimonious or fruitful. So we don't like to tell them. It's harder to learn from them and make a general lesson. So this is a very explicit example where we're preferring something that is less true because it has these other attributes. It's more lovely. And I don't mean lovely and, oh, there's a lovely tree. I mean lovely in the very specific sense that it is coherent, it works with prior theory, it's parsimonious, it's generalizable, and it's fruitful. So inference to the best explanation is about the search through the evidence and the prior theory and basically everything we know to find an explanation that's best. And what do we mean by best? It is an explanation that is both as likely as possible and also as lovely as possible. We want both things. And it's iterative. So we started out, and this is how I started out. I started out with the world market for 5 computers. And the reason I knew that is because I'd heard Nate Rosenberg speak about the world market for 5 computers as part of an essay to explain, to demonstrate how hard it is to predict the future. And, but when you look deeper, so that was one explanation. But when you look deeper into the history, you find additional explanations, such as the team underestimated the demand for a very specific product. Watson was impressing shareholders, and maybe Watson was manipulating shareholders. Each of those are plausible explanations, up to us to describe and decide which one's best. And we don't know for sure. We can't know the truth because we can't ask Thomas Watson. And even if we could ask Thomas Watson, we could ask, can he remember what he was really thinking when he said it? He might not have thought much about it. But either way, right, when we look for an explanation, we have to adjudicate, take all the evidence, figure out what's most likely, but also which story we want to tell. Hypothetical deduction is very different. This is what we think we are doing. We're not really doing this, but this is what we think we're doing, where we select one hypothesis, right? H1, that he believed, that Watson believed there was a world market for 5 computers. And then we usually have a null hypothesis. There was no such belief. And then we do a test to see, given what we see in the data, is it likely that H0 is true? That's basically what we ask. We never ask, is H1 true? We never prove H1. Instead, it's more of a preparing. We try to reject H0. There's a reason for that, which maybe we'll get to. Okay, so in practice, the hypothetical deductive framework relies on frequency claims. These are p-values, confidence intervals, standard errors, things like that. And these are all types of frequency claims. Now, here's the thing about frequency claims or frequency statistics. They are by definition inductive statements. They're statements about the sample, based on the sample, about the population. For example, and they're quite limited. This is a definition of a p-value. And a p-value is the expected frequency of estimating a statistic with a point value greater or equal to the estimate beta hat if the null hypothesis is true, if the true beta is 0. Now, there's some conditions to this. It's in a repeat random sample drawn from the same population. And we have to do this exactly the same way. So let's be clear. It's the expected frequency. So if I have a beta of 1.5 and a p-value of 0.05, that means that I have a 1 in 20, if the null hypothesis is really true, I have a 1 in 20 chance of seeing a beta with a higher value of 1.5 in a repeat sample drawn from the same population. Now, the problem is that this requires pre-specification, and which means that we need a sampling protocol, a measurement protocol, and a testing protocol. So we have to pre-specify everything about what we're going to measure before we look at the data. I'm going to repeat that. We have to pre-specify everything before we look at the data. So that's a big challenge for archival research. It's just really, really hard to do that and imagine that. There's another workaround, which Andy's going to talk about, which is mapping, which helps us a little bit with this idea that maybe if we examine every possible thing that we might have ever pre-specified, we can get a sense of what it might look like. But in practice, that doesn't really work. He'll talk about it because it's a beautiful, beautiful tool, and it helps solve it. And the second thing I point out, you'll notice in parentheticals, I have replication. A replication, you're replicating a pre-specified testing protocol. Somebody's already done it. And what you're doing is you're taking that as your protocol and you're replicating. And so that works too, which is why we like replication. I just thought we're not going to go into this detail, but I went and I looked at what are the pre-specification requirements that the FDA has for clinical trials for drugs. And I looked at this because this is a place where we really don't want to get things wrong because lives are at stake. So they're gonna impose the requirements that are truly necessary to believe the results of a randomized controlled trial. And it goes like there's no way we can do these things. This is really hard, right? So first of all, you have to get all the team together and decide how everybody's going to behave and what their roles and responsibilities are. Describe your research question, your control group, your hypotheses, your trial design, in the type of trial, how you're going to put people in each group, and then the nature of the interventions, when you're going to stop, what criteria you're going to use to stop either the intervention or the data collection, right? How are you going to make sure that the treatment is actually adhered to, right? What are you going to do about potential confounders, right? And we can go on, right? So this is just to point out, and I hope I've convinced you that pre-specification in most of our settings is really, really difficult. All right, so how do we evaluate likely? So this is back to likely and lovely. And here's this virtue of consilience. And we use figures of merit to try to evaluate using statistics if something is likely, a p-value, a standard error, or a confidence interval. But now we have a problem, because frequency statistics are only reliable indicators of repeat patterns in a sample if and only if we have all this pre-specification stuff going on, and we do that. So now we're in a situation where our evidence of consilience, our measures of consilience and goodness of fit, our figures of merit, if you will, are not reliable indicators of likeliness. So what do we do? Well, the first thing we do is we appeal to prior knowledge. That's theory, right? And that's good because coherence actually restricts our degrees of freedom, how much we're allowed to p-hack, right? And so this looks like control variables to account for prevailing theories, or we use measures already in use by the scholarly community. And then this constrains us a little bit. It tells us how to pre-specify, if you will. In general, we're more likely to be closer to the truth, the more our explanation ex ante is constrained. I apologize, I'm using a big word, verisimilitude. And I really am using verisimilitude because it's really, really fun to say. Verisimilitude, it's really fun to say. And it means close, as if the truth, like the truth. And it is the argument is that this is the best we can ever do. So in order to get a good explanation, something that's close to the truth, we require greater consilience, robustness tests, more patterns in the data. We look for patterns outside the data, right? So we look, this means that it's more likely. We often require greater coherence, which is consistency with prior theory, but of course there's no guarantee that adhering to prior theory is correct, because sometimes paradigms are wrong, right? And then we need judgment to understand given the context, right? And the problem about judgment is it's an opinion. It's not a truth, it's an explanation. Uh-oh. So I'm going to make one final point. This is what's called not a verisimilitude problem, but a verticality problem. Andy and I, together with Tim Simcoe, made an argument that that in order for testimony, basically what we write, for us to believe what we read in a journal, the testimony, the writer needs to be both competent and sincere. So sincere is easy. That just means that somebody's not lying. Right? And we generally believe that most of us and most of the writers in our journals are sincere. But the competence came into a question, not the sense that we think somebody's incompetent in a general sense, but if I make a frequency claim and I make a claim of a p-value, that is by definition a claim about what I expect to see in repeat samples in the population. I'm only competent to do that if I've pre-specified my entire trial. And so if you look in my published record, you will find frequency claims that I was not competent to make because I did not pre-specify, because I didn't understand how important that was. And that's a veridicality problem. So if we want to, if we want to use our hypodeductive framework where we have hypotheses and we test them, they're only appropriate if I can make a solid frequency claim. I can only do that if I can pre-specify. Instead, and this is what we will argue, is that we should be describing our research as we really do it, as an iterative process to make sense of the data. And we should clarify our judgments in their foundation and the values that we are weighting more heavily in these judgments. The truth is out there, right? And so I'm just going to have one final appeal to David Hume, right, to point out that most of what we know is from induction. And by induction, I mean what David Hume means and what the philosophers of science mean, which I'm making a general conclusion from narrow information, right? Hume concludes that we have no reason to believe that any inductive belief is the truth. And that's true of most of our knowledge, right? But that doesn't mean that we have no beliefs and probabilities about what we think is most likely to be true. And we should just clarify that in our writing. Okay? So this means that the criteria for frequency claims are rarely met, and that requires limiting explanations to claims of the best explanation for a data set. And I believe that's it for me. And I'm going to turn it over to Andy, who's going to talk about mapping, which is one of the responses to this, and then Sandeep will go after him.
Do you want to allow any clarifying questions?
Yes, are there questions that need clarification? I'm going to stop sharing. Yeah, does anybody have a question?
I guess not. Going once, twice. Sold to the man in the blue shirt. Okay, so I am going to talk. So Brent, that was great. That was the clearest I've seen in our discussions of this, and that really, I mean, the beginning of that was great. I sent you an email because I think there's some places we can go. Even though that was great, it was discouraging because he ends with, "No, we can never know anything. We're doomed, and we can't really pre-specify, and p-values don't mean anything." So what can we do? And it's true, I think, that the p-values are a big problem, but what can we do even to sort of begin to kind of know? And some of you have even seen this before. I'm going to talk to you a little bit about the problem. And I want to make sure I have the right presentation here. Oh, this is as embarrassed as I've ever been, I think. Hang on a minute. This is not the right presentation. My apologies. I'm going to stop sharing. Maybe we can have a question. Oh.
We just have a comment from the chat. Christina McAllen, sorry if I mispronounced your name, says, I need more coffee to grapple with the reality that we are doomed.
So we're not really doomed. I just want to, I was trying to keep my remarks somewhat brief, knowing that Andy and Sandeep were coming after me. And the summary is that once you recognize that you can't rely on the p-values, then you're actually quite freed to simply explain the data as best you can.
Yeah. Okay, I'm back. My apologies to everybody for that. Okay, so the problem that we're talking about, at least one problem we're talking about when Brent is saying is when we don't pre-specify exactly, we end up having lots of ways of studying whatever phenomenon we're interested in. So imagine that you are studying something and you're interested in, does consuming s'mores or Rice Krispies help CEOs influence profits? Now, that's already pretty narrowed down. You might enter a study like some people have done, where you're thinking, well, does food influence it? So then you try a whole bunch of different foods. And then you make a decision, well, where should I study this? Then you make a decision about how should you handle outliers? And then you make a decision about what's the best way to measure Rice Krispie eating versus s'more eating. Is it the total volume of marshmallows being, going into the firm, but maybe the marshmallows aren't going into s'mores. You can imagine there's issues there. Then there's what's the best model specification? What's the way the data was really generated in the real world? And then how can I best map that with my statistical model? And you end up in an end and you get a result. And then you turn around and you say, I have found this thing. I find statistically significant evidence that s'more eating by CEOs is associated with higher performance, which then goes out into the world and someone reports Hansel found s'more eating is associated with profits. Now notice, now we've turned it around from a frequency claim to this thing about the truth about the beta. Then somebody turns around it, the s'more eating leads to profits. Then pretty soon you have s'more eating, profits more, and little red cookbook, men with beards on the street, s'more eating. Then you have, Hansel gets to go on a TED talk. Then pretty soon they have, as Brent just pointed out, because this is so, what did you call it? Lovely. We cite it a zillion times and gets tenured and makes $1 zillion. And then sometime later, Gretel comes along and says, I'm not getting the same result as Hansel. What do I do now? That's the problem we have. And, you saw that in the examples that he gave. And there are others. And the thinking that we're going to fix this problem is we're going to pick the best model. That's what Brent said, and James Heckman had said, this is what we could do. We could use economics and we could narrow it down. And you can do that in physics and certain places where we have really, really good theory. You can really narrow it down to exactly what you're doing, perhaps in medicine. The problem is that we don't often have that case. So what's the alternative then? Well, then we can replicate. But I can tell you from having tried to replicate, they're seldom done and they're much more seldom published. And then how do you synthesize the different replications? So there's an alternative process out there that has been used in political science mostly, but in a variety of other areas where you kind of self-replicate right at the beginning. So rather than going through and picking one of the pathways to do from all your assumptions to your conclusion, you try to think of all the reasonable assumptions you could make, all the different ways of measuring s'more eating, all the possible models that might make sense, and you run them all. And so instead of looking through kind of a pinprick as to one estimate, you're looking through a window of a variety of estimates and trying to understand what the overall topography is out there. And then you got to present this. So this is the problem. And in the day when we used to write papers that were published in physical form, we could never have done this because we had to give like a table with an estimate in it. But now we can publish many pages of graphs. We can put Excel spreadsheets online. And so now it's possible. So now what we can do is we can published lots of different conditional results for those researchers out there who might have very strong priors. Maybe there's somebody out there that knows, marshmallows create a sudden sugar shock, and then therefore that's going to allow CEOs to make better decisions. And so I'm going to look just at this particular model. And then for people who don't know, you can give kind of synthesized estimates based on assumptions about that not knowing, or the diffuse priors. Okay. And yes, I said there's different ways of doing it. One of the ones I love the most is one when they went back and looked at shall issue right to carry laws and crime. And I think, and they understood why there had been such a debate on that for so long. There's an antecedent also from this in the psychology literature called the specification curve that Uri Simonson and Joe Simmons and Leif Nelson have proposed. And, some of these ideas also go much further back, to Ed Leamer and some of his ideas from the 80s. So here's an example that Luca Bacchicci and I have done. There are 6 papers on ESG investing, super, super hot area right now, that claim different links between social performance and financial performance. And the interesting thing is these all use the same data. They all use some data called Kinder, Leidenberg, and Dominy, and the CompuStat and CRISP business data. And they get different results. And you can see here's again, Brent, here's your number, 7,000 citations for a paper that shows a positive association. But then the next paper comes along and says, well, no, it's one depends on the measure. If you measure it one way, it's positive. If you depend on measure another way, it's negative. And someone comes along and says, no, it's misspecified. If you include R&D in the model, it goes away. Someone comes along and says, well, no, it's conditional on a bunch of other things. Some people can say, no, it's U-shaped. No, it's positive for one dependent variable, but not for the other. Okay. So what Luke and I did was we took all the different things that those people had assumed, the different dependent variables, the different ways of measuring it, the different ways of specifying the functional form, and then as it will turn out, critically, whether or not you're going to compare across firms or within firms, the control variables you use. And what we found was when we look at all of these, it makes much more sense about what's going on. We can now see a bigger sense of the overall results and make better interpretations. Now, I should say back here, if I can, the original authors were all very proud of their measures. They had decided that it was their measure that was allowing them often to get different results. And what we did is we graphed, this is Barnett and Solomon's measure, Hillman and Kleiman's measure, Hall and Rothenberg's measure, McWilliams and Siegel. It's binary, so the data gets noisy, Waddick and Graves. And we've got the betas from all the different ways you can estimate this, rank ordered from most strongly positive to less strongly positive. And these are all of the models that compare across firms for everybody, for all of their measures, all the different control variables. They could try everything. And what you see is you always get a positive coefficient. And sometimes, and a lot of the time, the 95% confidence interval doesn't include 0. That does not mean you can say it's statistically significant, but it looks always positive. So I look at that and I say, wow, looks like there's a contemporaneous correlation of ESG quality or social performance quality and financial performance, regardless also of the dependent variable. Oh, I guess this is just one dependent variable, but it's true for both dependent variables. But when you look across within firms over time, so that is a firm improves its score, what happens the following year? Now you have a much more mixed result. You can't really see things. It may be positive, it may be negative. A lot of them are pretty noisy and maybe it's really 0. And what happened in these papers is they were often crossing back and forth across this divide, getting a different result, assuming the cause of it was something other than what it appears now, and then making the conclusion. So we make these following observations. Across firms, social performance is positively correlated seldom precedes higher financial return. Notice we don't state statistically significant because we didn't pre-specify. We had whatever, 3,000 models that we ran. We can't claim statistically significance. So we're now giving our opinion about this, our sense of the good way to think about it rationally. And Luca and I argued that this approach should be part of our everyday toolbox. Well, with that, we fell down the rabbit hole because now I want to tell you, okay, so I think this really makes sense. Don't look through a pinprick, look through a window, think about all the things broadly, synthesize it with lots of different graphs, synthesize it with Bayesian analysis. But there's lots of confusion out there, and it makes it hard to do in terms of getting published. It's really fun to do, but it makes it hard to do getting published. Yeah, first thing we heard from reviewers are some estimates are significant. Aren't these the right ones? So if you remember like a graph back here, they'd say, well, over here, these are significant. Aren't those the right ones? Shouldn't I only pay attention to those? Well, of course not, because statistical significance, as Brent has already said, is about frequency. You have to pre-specify. We didn't do that. We don't really know a priori which model is the right one. Then which model is objectively better? Some of these models fit better. Well, you could use that. And in fact, if you use Bayesian analysis, it'll kind of use that. But the fit could also be based on the noise. So we don't it's a little hard to pick ones are best. And if you have no priors about which ones are model better, you could use the fit. But you might have a prior. You might think, no, I have a logic for why one of these is better. And even more incredibly, we heard from reviewers, turn the results around. So basically, they asked us to fish. They asked us to take all those results, pick the ones that seem to have nice results, and hypothesize about those. So we have a problem using this method, which is there's a lot of confusion about it. And yeah, so this is what we were told. Look at these. So here's another estimate we were replicating. Look at just these really strong estimates. Don't look at the bulk of the model. And one last thing I want to point out with this graph is we often in our papers report this uncertainty. That's essentially the uncertainty that we measure with a standard error or something like that. But if you look at the importance of not knowing how to measure the data or model the data, it's often much bigger. So objections we got also were things like, there's nothing wrong with the current practice. It's fine. We're all doing fine and knowledge is advancing, so go away. The analysis, the approach I'm talking about, model uncertainty analysis, can be manipulated. And it's true. There's no accepted way to select this window that you're going to look through. How big is it going to be? Really big? Really small? What should be the boundaries? And there are some ideas, but there aren't hard and fast rules on it yet. And so you could pretend to use model uncertainty analysis, look through a really small window, claim everything's fine, but you wouldn't and manipulate things accordingly. And most importantly, there's a big issue here. This changes our role as scholars in the sense that we no longer get to be able to, stand up at the end of the day and say, look, I have a finding here, and this is my finding, and it's right, because we can't use that statistical significance anymore. So now we end up having to say, well, yeah, we have results, and we think they go like this, and you probably should believe this, but you could believe something else if you wanted to, particularly if you already think that. And it puts a lot more burden on the reader. So I like this approach. I find model uncertainty analysis fun, accurate, and informative. I think it's more supportive of honest communication and learning, but it's yet to be legitimized. And there's another thing we could do. Just the easiest possible thing we could do, and kind of is the implication of Brent's talk, is we could just drop null hypothesis testing. We could just drop it and stop using the language. And I think Andreas Schwab is on here, would probably agree with this. Instead of doing tests, because very seldom do we actually do abide by the rules. Just report the data and the coefficients and the standard errors, and then write my preferred explanation. And mapping is a way of then providing some oomph behind that. But that's only, we could actually get part of the way there just by dropping the language we use. Okay, thank you. Questions?
Yes, thank you, Andy. I'm going to leave it open for a moment for questions. Rohan has a question, which is, can there be model uncertainty about model uncertainty analysis?
Yes. So that's the window problem. So the problem is there's multiple model uncertainty problems in model uncertainty, Rohan. So the first one is this: how do you pick the window? And offline, we can talk about that. I mean, what we did is, if there's a body of literature, you can look at what the prior people seem to have had about the appropriate ways of doing things. If you don't have that, you can sort of query your own sense of where you're uncertain. You can do it ex ante by looking at the likelihood ratios, which is another way you can do it. Then there's another element of model uncertainty analysis, which I think is subjective, or is an issue, which is the Bayesian part. What assumptions should you assume that people will have about the prior probabilities of these different ways of doing things? And I think we can get around that by having online appendices where you could actually input your own priors, allow the reader to input their own priors, and have it spit out then an aggregate estimate. And I'm working on some Excel programs to do it, but it's not fixed model uncertainty analysis. It's still got some uncertainty.
So I just want to push on that a little bit, Andy. So it sounds to me like you need a lot of judgment to figure out what to do, and which models to do, and B, that one of the determinants of what you conclude is what you believe when you start.
Well, if I can answer the first part of that question, there's a lot of judgment. But what I like about model uncertainty analysis is it makes the judgment more transparent. Because basically what you have to do when you say pick a measure or pick a model is you have to say, here's the range of models I could pick. And you have to make an argument about why that is. And generally in our papers right now, we just go hypothesis, hypothesis, hypothesis. Here's our model. And now all of a sudden we have to say, well, here's our model, but there's a variety of ways we could have done this. And it makes that very clear. So that's one. I think we all are engaged in judgment all the time. And now we just are admitting there's some judgment and there's some uncertainty in that judgment. And then the second thing you said was, we're too old to remember what we were just talking about. Judgment.
My name is Brent.
Does anyone remember? I don't remember what Brent's second point was. Definitely there's judgment in it.
Oh, yes, right. That your where you wind up with, like where you wind up in the end, is highly determined by what you believed before you saw any data.
Well, it's determined. It doesn't necessarily have to be highly determined. It's based on your priors. And this requires, if you go the Bayesian direction of this, and this is another uncertainty in model uncertainty. If you look at some of the people, Simonson, Nelson, and Simonson, they are pressing to stay within the frequency framework. The null hypothesis testing kind of p-values and frequency. I don't see how you can do that once you have a variety of models. I believe we're going to have to think more like Bayesians, which I think we do, which is given what my expectations earlier, how strong they are, that influences how I interpret the data. My sense.
So Andreas has Andreas has a question, then Erwin does too. I want to get to both of them. But since Andreas is related to this, he's asking, well, if you don't use a p-value, what should you look at?
Who's asking that?
Andreas in Schwab. And and then he points out correctly, of course, that confidence intervals are essentially the same information as a p-value, just expressed in a slightly different way. And how should we determine if we have quote unquote something in the data?
Andreas, I think you're teeing me up because I think you're a Bayesian. I mean, I think you have to think about your priors and think about the additional evidence that the data is providing and look at how, it affects the likelihood ratio. But even though then, and this goes back to the window, you're thinking about the relative likelihood of different models conditional on the set of models that you've chosen. But Andreas, I'd like to hear what you think. Can he speak?
I know he can speak. I just don't know if he can speak in this forum.
We can make that happen.
Okay.
Andreas, if you have a microphone, you can.
Can you hear me now?
Yes, great.
Yes.
I of course, I completely buy into the weaknesses of the p-value, but it always leads to the questions of what to do alternatively. And Bayesian is, of course, a very complex alternative world. So I was kind of wanted to pick your brain with regard to wouldn't be the stronger focus on effect size be a potential alternative to an intermediate step that we just look more what we have in the data and see the dispersion of effect sizes, predicted effects, as a way to step away from the p-value evaluation, but still deal with uncertainty in a very more probably descriptive way without buying into a completely different philosophy on how to estimate and evaluate uncertainty.
Yeah, and I hear you. I don't want to take up too much time here. And Andreas has already pointed out these 95% confidence intervals only have meaning in a very precise way about the probability of a particular method find that the coefficient would result in that in the future. And we often misinterpret the confidence interval. And I think Andreas, another way of saying it is we could make these graphs and take off the gray region, just show the black lines, just show the effect of B, maybe no longer call it B, but call it out in real material terms, like percent increase or something like that. And then look at these overall patterns and then make personal inferences based on our own priors about that.
Yeah, I'll add the model uncertainty folk, they kind of follow this look, and they'll look at the beta and they'll report one standard deviation each way and say here's a range of likely betas. I don't know how they got to one standard deviation. That seems arbitrary to me, but that is a norm, I think, in the model uncertainty, or a suggestion, shall we say, from those who
if I may just say, one thing that I think this does allow you to do is really understand what conditions the results. You realize, oh, like here, oh, I see, they all look like this if you make that assumption, and they all look like that if you make this other assumption. And then within that, you can begin to get a sense of how reliable it is. But it's true, frequentist analysis is so great because it's so easy and it's so clear, but it's conditioned on all kinds of things that we don't do, so we can't use it. So go ahead.
I didn't mean to interrupt you.
I think we should probably move on. I think to Sandeep, and we can always circle back to this conversation later. No.
So Christina has a question in the chat, which is actually an excellent lead-in for Sandeep. So I'm going to use that. Christina is basically pointing out that data themselves hide many assumptions. And so if we just let the data speak and conclude based on the data alone, that's really dangerous. And Sandeep will agree with you. In fact, that's the point of his talk, to think about what we should do that's outside the data. And then Erwin, I'll just point out, had a question about what to do given our community and what we're saying isn't generally accepted across the community. And I'm going to defer that until after Sandeep's discussion.
Although if I can just jump in quickly on that, I think our community is ahead. You know, I think SMJ is one journal which is remarkably open to this stuff. And we can talk about that later. Okay.
Okay, let me just upload the slides. I hope everyone can hear me. So thank you all for sticking around even after the main presentations are over. It's intimidating for junior faculty to follow Brent and Andy, but I will try. So what I'm about to present is based on a paper that I'm working with Brent and my co-advisor, David Kirsch from Maryland. So this is based on, so there are some comments about how are things perceived by others. So it's really a response to my experience with that. My job market paper was on the early American automobile industry. And, you know, Brent being my advisor, I made the mistake of trying to follow some of the things he told me to in the job talks. And I started getting pushback. Why are you doing this? This seems very hard. You seem to be spending a lot of time going through all these different sources. What is the point? And, you know, I thought at the time it was a cheap shot at me. And then once I had a job and I knew I could pay rent, I decided maybe I should really think a little bit more seriously about why is it that I'm doing this, and I didn't have a very good answer, so I thought I went and investigated it a little bit. So the argument I will be making is that, as Brent said, you know, most of the time in a strategy we are engaging in inference to the best explanation, where we have a bunch of candidate explanations and we have to choose the best from among them. And Brent in the beginning talked about a number of virtues that we need to make judgments about for us to be able to select this best explanation. The challenge we have is often when you rely exclusively on statistical analysis, its machinery does not have the capacity sometimes to, first of all, to generate explanations, and often it is not able to eliminate explanations. So to make these judgments about explanations, what we need is information that is perhaps outside of the statistical data set, and we need a way to uncover this information. This is where historical methods come in. Historical methods essentially provides us a systematic way to uncover the information that we need to make the judgments about the virtues that Brent was talking about earlier. And so essentially what it does is it allows us to improve, historical methods allows us to improve judgments about loveliness and likeliness, right? So I'm not framing historical methods as like against statistics. I would frame it as a necessary complement to statistics when it comes to inferring to the best explanation. So before I proceed, I just want to say I am not going to give you a how to do history manual. Everybody wants me to do a comparison between history and qualitative. Whenever I talk about this, I will not do that. And this is not going to be a what's wrong with stats. It's already been done, right? 2 people already did it, so I'm not going to do that either. So just to review some of the things that were said, you know, when we are, what we are often doing is we have some observed evidence, and we are coming up with different conjectures. And from among them, we have to select the best explanation. And the question is, how do we go about doing this? And as Brent said in the beginning, philosophers of science have said that, look, what we need to look at or do is make judgments about loveliness and likeliness, right? That's what we need to do, right? And ideally, an explanation will be both lovely and likely, but often what we find is they are in tension with each other because of the virtues that Brent talked about. So the challenge we have is, I mean, it's not that we are not doing this, right? So we don't necessarily call this loveliness and likeliness, but we do this. You know, every time we get rejected from a journal, we resubmit to a different journal, we reframe it, right? We reframe it to make it more lovely to that journal, for it to match the conversations that are happening in that journal, right? We do this, we all have favorite theories that we try to pick from. All of our papers are filled with paragraphs about how this is generalizable. The solution is very generalizable. These are all things that we are doing to really, when we do this, we are really making a judgment about loveliness. But the problem there is that when we rely on our favorite theory to choose the candidate explanations, you may miss out an explanation that is closer to the truth, right, from your consideration set. And this is called the bad lot problem. And the challenge is statistics inherently does not have a way to overcome this issue. Okay. Second thing is, when we think of likeliness, we love our p-values. We really do think of likeliness, right? The statistical likelihood is how we think about likeliness. And as Brent said, look, I mean, the statistics understate the likelihood that the relationship is random. That's ultimately the problem. And you may say, well, why don't you just run an experiment, right? Which is a question I got in my job market. You can see I'm still a little angry about some of the questions from the job market. And the issue is that the kind of questions that we ask, the singular, very non-trivial RCT derivable causes are not the norm. Right? For a variety of literatures, that's not the norm. So it's not that statistics is not needed. This is nothing against that. It's just that it is insufficient to make these judgments about the different virtues that Brent talked about earlier. So the argument I will make is that historical methods actually complement statistical methods to improve our judgments of likeliness and loveliness. That's the argument I would like to make. So what do I mean by historical methods? So what they're not is, unless you're doing an experiment or unless you're doing some sort of ethnographic study, most of the times we are studying the past, right? And just because you are studying the past does not mean you're using historical methods, okay? It is not qualitative method by another name. A key distinction being qualitative method involves direct observation, be it in interviews or ethnography, it involves direct observation. And sometimes we say, oh, well, I have a bunch of dummy variables. Oh, I give a timeline of what happened. I have some background information. It's all good, but that doesn't mean that you're engaging seriously with the historical methods, okay? So before I talk about historical methods, I have to talk about the historical record. What is a historical record? It is a collection of ascertained facts. That's what it is. And historical record offers us two main advantages. The first one being, now imagine we want to understand a decision taken by a CEO. You're able to think about, okay, what are the choices that the CEO had when he was making the decision? I can look at the firm records and understand from the meeting minutes with the board of directors, how did the board of directors perceive it? I can look at the media and understand how did the popular press perceive it? How did the customers perceive it? I can probably look at the firm records and understand how did the junior employees perceive it? So for a same instant of time, for a same decision, what I'm able to do is understand broad aspects, how different people perceived it. This is what is called the wide view. So I get to be in multiple places at the same time, right, with the historical records. And then there's the long view where I can take this decision and see how did this decision affect the future of the firm? What happened? What are the consequences of this decision over time, right? And we need this to reveal what are the outliers, what are the turning points, because at the end of the day, often it's the outliers and the turning points that are interesting to us. So it gives us the wide view and it gives us the long view. That's what the historical records offer us. Now, just like statistical methods, it refers to a series of tools, right? We have OLS and probit and tobit and all sorts of bits. Historical methods also refers to a collection of tools. And what these tools do is they help us to interpret information about the past. That's what it does. And I think there are three tools that is very relevant to strategy scholars. The first one being hermeneutics, Hermeneutics really is about understanding the actor's perspective. What are the choices that the actor had? What were the actor's motivations? How did he perceive? What were the circumstances under that he was trying to deal with, etc. Right. So hermeneutics is about the actor. Then what we want to understand is the environment around the actor, the time and the space that the actor was in, because often we make this assumption that the way our environment is the same as what the environment was many years ago and make judgments based on that. We should not be doing that. So it really helps us to understand the time and the space that the actor is in. And the third one is source criticism, as it was already raised in the chat, where the records are not there so that we can do analysis and submit to SMJ and get tenure. The records were created for a different purpose. What was the purpose of the creation of the record? Because that can affect the insights that we generate from it, right? Why did it survive? And more importantly, what is missing? And what these tools allow us to do is gives us a systematic way to uncover the contextual information that we need to make judgments about the virtues, right? So historical methods, what it does is it complements the statistical method. So when we think of likeliness from a statistical perspective, what we are often thinking about is, oh, does the measure match the construct, right? Does my statistical model design make sense? Or does the p-value and the r-squared values make sense, right? Not saying that's not important, but we need to complement it with historical methods to understand, does this insight, does this explanation make sense for the actors who were there? Does it fit the context? And if the explanation is true, I should see it across multiple sources. Am I able to see that, right? So it complements statistical methods to help us make these judgments. When we think of loveliness of an explanation, we often think about, oh, how well does, in statistical terms, we think of how do our measures fit the prior measures? We often see this, for example, in patent literature, right? We'd like to repeat the measures. Are we able to replicate the results? Are we using the same data sources? Does it make sense? Do we have fewer parameters, right? So all of this is important for loveliness, and I'm not saying it's not, but we need to complement that with understanding what is the story, what is the narrative. And narratives require you to confirm with the context, that with evidence that this is what actually happened, right? And what are the boundary conditions, rather than saying it's all generalizable everywhere. Historical methods gives us a more accurate representation of where exactly an explanation is generalizable, so that we can make judgments about loveliness. So in the paper, when we finish writing it, what we are planning to do is, for both loveliness and likeliness, we will talk about how each of the historical methods helps us make judgments about it. For now, given the time constraint, I'm just going to talk about likeliness at a high level. So how does hermeneutics, for example, help us make judgments about likeliness? Likeliness, just to remind you, is about how close to the truth are we, right? So it really helps us understand the cause and effect. Was it relevant to the actors? So to go back to the original example that Brent used with the GM acquiring Fisher body. In 1978, the paper comes out about holdup and asset specificity. The decision was taken in 1926. In 1926, where the decision makers at GM, were they really concerned about holdup and asset specificity? Is that what they were discussing? What other choices did they have? This is what hermeneutics helps us ask, right? Before deciding whether it's a likely explanation or not. Contextualization. Contextualization is about uncovering facts to reconcile. And I will explain it with an example. There is a very nice paper by Brzezinski and Hounshell that explores the success of the Japanese cotton spinning industry. And the argument they make in that paper is that the use of British cotton spinning machinery was vital for this success. And they also show that government mills got subsidies to be able to purchase this machinery, right? So a natural, very statistically supported, probably explanation that comes out of this is government support led to the success of cotton spinning industry, right? But what they do is they go to the context and they uncover facts. So if you look at the cotton that these mills were using, the cotton does not fit the British machinery, which means that the machinery was just sitting there, right? These factories were actually using very inefficient production method. So they uncover a series of facts that does not fit the explanation, and it helps them to make judgments about how likely that explanation is, regardless of whether or not the statistics, the p-value is there, right? Because it does not fit the realities of the context. Okay. The third one is source criticism, where, essentially, if the story is true, we should see it across different places, right? And historical methods gives us a systematic way to go and explore these different sources. So when one of the papers is on that I have out is on the early American automobile industry, and as a PhD student, when I was discussing with Brent and David this paper, one of the most frustrating meetings is always, well, Sandeep, does this hold true in the firm records? Does it hold true in the media records? Does it hold true in that record? Does this hold true in this record? And they basically forced me to go and look at all of these things, which means that it's a way to make sure that the story is consistent across different methods. And historical methods, historical records using historical methods offers us a systematic way of verifying this. So, and when you're looking at these facts, what usually happens is you will come across facts that do not fit the ideal explanation that you probably had in mind, right? We all have biases, but that misfitting fact is what forces you to go and look for new explanation. And so inherent in the system of historical explanation and looking at the records is the solution to the bad lot problem, where you will identify facts that do not fit the explanation, and you have to look for and that compels you to look at alternate explanations. So what historical explanation does when we are doing this judgment is that it's really revealing the cost, of loveliness and likeliness in terms of those virtues that Brent so clearly talked about in the beginning, right? So you engage in contextualization and you identify more facts. Yeah, you are going to come up with a more consilient explanation, which means it's more likely. But at the same time, when you identify more facts, you are going to identify more boundary conditions, which probably affects the generalizability or parsimony, which probably affects the loveliness, right? You can see that it's intention, it helps you make judgments about it. Similarly with hermeneutics, you can make sure that your explanation is rooted in the actor's reality. So when you come up with your statistical model, it'll probably be a more likely explanation what you have. But the problem is you can no longer impose your favorite theory onto it, right? You may not be able to do it, which again constrains loveliness. So it's really what it really does is reveal to you this cost of likeliness versus loveliness in terms of these virtues. So what it allows us to do, if you think of each of these shapes as representing each explanation, it helps us create this mental map of these different virtues. It could be that you may prefer an explanation that is very consilient but not ranking very highly on the other virtues. You may prefer an explanation that ranks very highly on the other virtues but not very consilient, or you may prefer a balanced explanation. But you have to make that judgment. But what historical methods does is reveal the costs and helps us make these mental maps that helps us to make this judgment. At the end of the day, inference is a choice, right? I mean, this idea of best explanation, there are no truth claims here, right? So it's a scholarly judgment, right? So if we have multiple explanations, what we want to do is create a mapping. And this is what historical explanation does, where we can actually create a mapping like this of the explanation of loveliness and likeness. It is easy for us to eliminate the green explanation. It is very obvious. The green explanation is not there. But where we really need this to make the judgment is for that comparison between the violet and the red and the yellow, right? What historical explanation reveals to you is, look, yellow is perhaps more lovely and violet is perhaps more likely and red is perhaps somewhere in between. and you have to make that judgment, right? At the end of the day, you have to make that judgment, but it reveals to you the ordering of it. Okay, so this is not intended in any way to say, statistics don't matter, we should not go and do a statistical analysis. I think of myself hopefully as a statistical person, but the argument is that we need to complement, for us to make judgments about loveliness and likeliness, we need to complement statistics with historical methods, because statistics does say something, the patterns do mean something, but we need history to give the circumstantial evidence to convict, as is said in this quote. So the fundamental argument we are making is we need to be able to make judgments about loveliness and likeliness to pick the best explanation. Statistics on its own has certain limitations that prevents us from making this judgment. So we need historical methods to help us make judgments about the virtues, which helps us make judgments about loveliness and likeliness, right? So that we can make the choice of the best explanation, right? So it's not that when we think of alternate explanations, it's not that we are often thinking about is one explanation better than the other. What we are actually in effect saying is that which is more likely versus which is more lovely, right? And I think we may have a much more productive discussion if we really think in these terms. So just a very quick note, how I practically do this, right? So to me, it's all about really going deep into the context, really understanding the context. And often when you're studying the past, I know books are underrated and most people don't like reading books, and historians write a lot of books, so we don't really deal with historians. I get it. But a lot of historians have probably really thought about some of the events that you have thought about, and they may have real genuine insight on what is happening that will really help you get to the best explanation, right? We should be more explicit and transparent about the virtues. That's what I try to do. What is the cost, right? Is it for achieving consilience? What is the cost? We should take alternative explanations seriously, and to generate that, I use historical methods, and it's really important to recognize the boundaries of the explanation. So I will just leave you with a mental model. This is how I think about it. Not. So we all have biases, knowledge. We all approach often a data set with like, I would like this to be my answer, right? We all, or when we have a question, right? And often the question is based on that bias, right? And we have to make judgments at different stages. Like Andy said, the first judgment I have is, should I really, we have a set of known candidates, should I expand outside of it? If I make the judgment yes, I go and identify historical records that is relevant. It could be media reports, it could be firm records, all sorts of, even Instagram stories. We have papers that is actually looking at Instagram stories at historical records, right? I go and interrogate those historical records. I really try to think about what are the different narratives that are emerging from the records, compare, and each of those narratives essentially represents a different explanation. Engage in this comparison in terms of virtues between those different narratives. And then I go back to the cyclical process of, okay, is this enough? Should I search for more? At some point, I make a judgment that, okay, I'm not really seeing anything new. I'm not discovering additional information, at which point, based on the narratives that I have constructed, I infer to the best explanation. This is my process. This is not like a official historical department process anywhere. This is my process, okay? So with that, thank you so much for giving me the chance, and thank you so much for listening.
Excellent. Thank you, Sandeep. I do hope that was at least somewhat responsive to Christina's question about what to do. And the big lesson is that the story, the conviction of a mechanism is rarely going to come from the data alone. We have to look to the context and understand our context, and historical methods are a tool to do that. Is that a fair statement?
I would, yes, I would say that. Yeah, I hope, and Christina, like, this is a just to respond, the source criticism is not something that in strategy we really think about much, but imagine the amount of real estate that we allocate to generalizability. Often I find historians allocate more than that much real estate to source criticism, to really think about the sources. So letting the data speak is really dangerous, is something that has been very much embraced from them, and that's something that we can learn from them.
Yeah, and to the point, that was, yeah, Christina was saying we should criticize the source, which is CompuStat, any administrative data for that matter. We have to think very carefully. I want to turn to Erwin's question, and this is, we have actually a host of prepared questions, and Erwin, you just happened to ask one of them, and his question was, the great majority won't understand an approach that is not mainstream, and I think he was referring, Andy, to mapping. Any advice on how to handle that? And Andy, you have your camera off, but if you're there, I'm interested in what you think about that. And he clarified he's specifically thinking of reviewers. And Andy, you're muted.
One more time. The great majority of people will not.
What do you do if you're mapping, or you're writing in an IB? I'm going to generalize it. You're writing in an IBE framework or methodology or view, and you're not going to put in hypotheses. You're going to put in your maps, and your reviewers don't get it, or the editor doesn't get it. What do you do? And you're not tenured.
Well, I have two answers. I think it's tough when you're not tenured. It took me 3 rounds to get one of our most recent papers published, and you think it's bad in strategy, you should try it in accounting. And the other paper, we went multiple rounds, and I think it's tricky for if you're untenured. I think SMJ is pretty safe. But I think this is what you should do. And I think in the long run, this is where we're going to go. And if you're going to be, it's a little bit of a choice about who you want to be as a human being. I mean, I hope we got into scholarship because we wanted to know stuff, not just play the game.
Yeah, I have this difficulty that once it took me many years into my career to understand the problems with the statistics we're using. And then once I did, it's really hard to use them in the same way. And then the question is, how do I write in a way that's future-proof? And I've noticed some tricks that we can get away with that seem subtle, that seem to make a big difference. So one, a frequency statement, if we're not competent to make it, like you see the language around that, such as firms who do more R&D outperform. And this is based on a regression that related R&D to some measure of performance. And if we change the language to firms in my sample who did more R&D outperformed, we're changing it from a general statement to a specific statement about our data. And we're reporting a pattern in our data as opposed to claiming there's a pattern in the world. And these are the sorts of statements that you can make and you can write, and they're future-proof in the sense that you can't come back and get caught on a general claim that that wasn't justified. But at the same time, the reviewers aren't even going to notice them yet. And so you can probably, I'm not advocating that we're not explicit in what we're doing, but under pressure, that's one thing that, like, there's little things that one can do to be true to what you can say in that way. The other suggestion I was going to make is there's now a host of writings about this. So if a reviewer comes to you and says, please p-hack the data with my best explanation and put it as a hypothesis, or you must use a hypothetical deductive framework here, I don't like the way you're writing, you can reference articles that have made the claims in our journals that we shouldn't be doing this. And some of them are SMJ editorials from the editorial board. Andy wrote a paper, and he generously put mine and Tim's name on it. That's an AMR on testimony. And these are very strong arguments about the problems with writing in the traditional way. And so you can reference those to the reviewers and challenge them. Hey guys, I hear what you're saying, but we can't keep doing it this way.
I'd love to hear what other people say about that. And I do recognize this is a big problem. And we need to somehow get into the Journal of Loveliness, otherwise known as Administrative Science Quarterly, and make this, credible. But I don't know, I'd love to hear from the audience. The audience is a strange thing. I'd love to hear from my colleagues. Apparently not. All right, I'm going to cold call.
Well, before Andy cold calls, can I ask one more question?
Sure.
Of Andy, because you've already referred to us a little bit. Well, here's Charlotte saying that please do something more abductively. So that's good. In the reviewers. The other question is which editors are more favorable? I'm not going to say the other question, which ones are not? Where?
In strategy?
In strategy.
Well, I think Alfonso at Management Sciences would be psyched. I don't know where he is, but Lamar Pierce, I think, is super psyched. I think Rodri at SMJ, I think SMJ is pretty much safe. And Miles, where, in the strategy science, I think that, so I'd be perfectly happy. There are lots of people that are behind this. I think ASQ is tough because it loves lovely, right? And that's what it publishes. Andreas got his hand up.
Well, my perspective is a little different on the review process because we always think of the review process as us as authors, but we're all involved on the review side as the reviewer. And so thereby we are in a position to actually ask others to kind of probe this or encourage others when we see things in this direction. And I think that's we should not underestimate that power with regard to supporting change processes, not as authors, but as reviewers and editors.
I agree. That's definitely something. But we do have this tension, and the tension is between the game and the career, and trying to do things in a way that's more humble. And, you're advancing your career, and humility can sometimes not go well together.
If I may jump in that, I see two strategies. So we don't want people that we convince them and then they become martyrs. So they work for the cause, but they just get nailed on the cross and don't publish anything and don't become tenure.
Yeah.
So we want the people that are on this call and already sensitized in this, that they are successful. And how can we support that? So if this is to some degree a field, it's socially constructed, it is to some degree a game that we're playing. We have to make sure that we play the game, I think, right. We recognize what the limitations are. So I would say one of my experience has been my first paper I submitted without stars on the tables because I worked with a labor economist who did not buy into why should we do a p-test when there is no sampling? We had a population. And of course, that got rejected right away. I've never submitted a paper that has at least stars in the tables, because one of the reviewers' feedback was that you don't even know how to construct tables. And thereby, this paper is just not ready. So what's the strategy? You got to differentiate, I think, between your first submission. You want to get an R&R. And after the R&R, you can push more and more stuff in there that you think should be in there. For example, simple strategy, in your last attempt, I tried to switch from p-values to reporting CIs. Which looks different, but most editors at that stage will say like, sure, CI is exactly the same like the p-value, conveys the same information. Why should I stop that? So most editors let you do things. When you're at the end stage, if you come in with CIs right away, people will think your paper looks different. Do you even know what the game is? Should I pay attention to you? So I think in that sense, we have to be a little strategic. And I also think we have to have portfolios. I have papers I believe more in that push the envelope, and I have others where I think this is more mainstream, but more sure. And they will help me to be able to do the stuff I really believe in.
So it is a long game. I would add one thing to what you said, Andreas, which is if I'm going to present my analysis in a slightly different way, every time I do that now, I explain why I'm doing that. Like, I don't simply do it and assume everyone understands this is the way and this is the reason. I justify it relying on some published work and principles that we were describing, the three of us were describing, or things we didn't describe, that we were describing today. So in that sense, we challenge the reviewer and the editor is like, well, if you don't like this, here's, explain to me what's wrong in that sense. But I acknowledge that
I think,
yeah, go ahead.
To the junior people, reach out to the senior people, first of all. And I think picking editors is super helpful. And at least, trialing papers and stuff, those are super helpful. And I think that there's a merry band of people who are really enthusiastic about this. And so I think they'll give their time. Brent particularly will give a lot of his time. And that's a joke. And, so I think from a practical point of view, that's the way to go. And I think that there are advantages to thinking clearly in the sense that you move faster. I have spent so much time on papers, because of the problem, Shakespeare's problem. Oh, what a tangled web we weave when we conspire to deceive, right? I mean, you're trying to make your story hang together and it doesn't quite hang together. And I find it liberating to not do that anymore. And so I think and it's related to Christina's thing in the chat. There's a bigger culture change here that's going to be slow. And if your career is number one, this may not be the route for you right away.
I just want to say one thing about the time pressure issue. So I think one thing that sometimes as junior faculty we don't do very well is collaborate with others and kind of help split the load. Because one advice I got was, it's important to get into, with historical data collection, as you can imagine, it takes months, years. It's important to come up with a data set that you can get multiple papers out of, but not only that, collaborate with people with whom you could possibly share data sets just to affect this time. Because if I for example, I'm working with a historian on a paper on the Italian fashion industry. I don't speak Italian. The historian is, I'm really using the historian here, right? And the historian works with me. So I think some of this timing issue, we have to be very deliberate in our co-authorship strategy, I think, as junior faculty.
I just cold called on Xavier because Xavier always has interesting things to say, and he's got a new journal that he's working on, which is potentially the perfect outlet. Xavier?
Yes, well, can you hear me, by the way?
Yes, we can hear you.
Yes. Well, the motivation for the Journal of Management Scientific Reports, for not to name it, is simply to open up more avenues of the type that you folks are pioneering quite objectively. The distinction that we perhaps are struggling with, and in fact, it was the one comment I was going to ask of following your presentation, Andy, is to what extent we are working to a hypothesis or an explanation of a relationship versus working with competing predictions in the three approaches or frameworks that each of you presented. I sense a slight distinction between the three, and that the journal will be dealing with what if you have a particular prediction to work with. But there are clearly other situations where each of these three methods or approaches, I probably shouldn't call them methods, may have more bearing for the field. But I would simply add, I think there is growing in journals for the more inspired and evidence-based approach that all three of you are advocating.
Xavier, I'm glad you're not in marketing. So I'm going to ask you some questions, and then I'm going to answer your question. When does the journal first accept submissions?
Well, we hope to be online on May 15th.
And why is this journal likely to get to be important?
Oh, well, thank you for the non-marketing questions. Essentially, Journal of Marketing Scientific Reports will be centered around hypothesis testing, which has a cumulative flavor.
But it's related to JOM, right? The journal.
Yeah, it is. I fear that some of the Justin and others here may be nervous about the direction of this conversation. It is related with journal management, and obviously, what its existence telling us, like before the existence of Strategic Entrepreneurship Journal, like Global Strategy Journal did for SMJ, just to be clear, is that there needs sometimes to be dedicated space for people to play in the type of, I think one of you used the expression sandbox that you were talking about. So hopefully there will be more of those. I suspect it may be a while before we have a journal, say in strategy history, or maybe Sandeep thinks that he knows of one, but for generalized approaches that have statistical and philosophy of science standing behind them, of which Brent and Andrew were obviously a part of, I think I see the space. And again, remember the acronym JOMSR, and more announcements will be forthcoming.
So in answer to your question, though, yeah, I mean, what drives Andreas crazy and everybody is that not only do we misuse the frequentist analysis and then make claims about p-values when we can, we then very frequently invert what we determine in frequentist analysis and make a claim about the truth of the hypothesis, which we cannot do. And you're bringing up that if you're going to make any claim about the truth of the hypothesis, you have to have thought about, in a Bayesian sense, what are all the other rival ways that relationship could have been generated. And so what we really should be doing is either ruling out all those rival ways with an experiment or something like that allows us to get rid of most of the other explanations, or be explicitly recognizing that there are all these rival ways. And what I found so interesting about Sandeep's talk is this is exactly what Sandeep is talking about. He's thinking about what are all these rival ways, and that we need to consider those when we're making then our own conclusions from the data. And when he mentioned the small lot problem, or the bad lot problem, is that's exactly the issue. If you start off with only one way of thinking about it, then really all you can you can use frequentist analysis, but you can't really reason back to the probability that that's the mechanism or the true relationship, because you haven't considered all the other ways that relationship could have come about. We need to do that more. And Sandeep, I think, did a very nice job, and Brent, by saying about, how you might want to think about that process.
So I want to add something that didn't come up, and I just want to emphasize it. One of the things, and then I want to get back to Christina's point as well. So one of the things that happens if you're doing hypothetical deductive work and you're pre-specifying, which is an interesting thing to do, and there's a role for that when we do experiments, and even when we do replications, you need to be constrained in order to get reliable statistics. But the constraint means that as you go through the process of working with the data, you can't change your analysis, and you can't investigate models that you didn't, and explanations that you didn't consider before you got to the data in the first place. So you can't learn from the data. You can only use the data for testing. And once you start learning from the data and adjusting your model because you've discovered something of interest that you need to or want to understand, you've now moved into the realm of theory building as opposed to theory testing. And that's such an important part of our work. And indeed, the whole idea behind inference to the best explanation is to acknowledge that that's usually how we work with data. And it's a method to help us understand why we have a preference for certain explanations, given that we're now using the data to generate theory and generate explanations. And there's really no difference between an explanation and a theory in this context. And that's just like such a fundamental point about how we work with how work in strategy is usually done. And what Andy and Sandeep and I are trying to promote is that we describe our research in that way. We don't use the language of testing, except in the limited circumstances where that's applicable, which is when everything is pre-specified. To Christina's point that about the reviewer population is undertrained, and of course that's true, there's no answer to that except to keep doing things like this, because every one of you is a reviewer, or trying to work with journals to get in front of editorial boards. But
I'm going to make a suggestion.
uh-huh.
In AOM and SMS, just like we have junior faculty consortium, there should be a new reviewer consortium. Here you go, half a day of teaching reviewers. This is one of the things you should think about.
I love that new reviewer consortium.
So I have a question for the group, and I hope someone will weigh in. I used to go to these kinds of things and look at those guys with gray hair, and almost always were guys, pontificate. And they didn't really understand my world. The junior scholars, what are we missing about your world? Or if you'd just like to tell us that we're full of it, that's also true. It's very cathartic, I've discovered, although not necessarily good for your career. What are the junior scholars from this feeling? Like, do we understand? Are we out there? Is this crazy? Does it make sense?
Can I start just because I'm here?
Yes, you're a junior scholar. There you go.
So the first challenge I had is the papers that we read in our seminars are different from the papers that we are asked to write based on this framework, right? So you spend 2 years preparing for comms, and this was a huge challenge for me because suddenly I wasn't sure how to write the paper, right? This may change as we have more samples and things like that, but this was challenge number one. And maybe the answer is for the senior faculty members who are running PhD seminars here to include some of the papers that are more true to some of the ideals that has been discussed, because it's very hard to learn one thing and produce another thing for junior people from a practical perspective as a starting point. I'm sure others have other things to talk about.
Shall I go back to cold calling? Or should we just end it here? Maybe people are ready to be done. What do you think, Brent?
I think that we've ended it. We can end it here. I really want to. I just really want to emphasize. I love the idea of a reviewer consortium, and I think that that's something very practical that we can work towards. And so I really want to thank the audience for that suggestion. I can't remember who came up with it, but that's just a wonderful contribution. I want to thank everyone for showing up. As you can see, this is something that Andy, Sandeep, and I have our hearts in and believe in, and I'm just glad that we're able to start building a community around that. So thank you very much for being here. Erwin also wants an editor consortium. And Ryan has a nice editorial and editorial note as well. So thank you all for being here. And I remind you all that in 2 weeks, we have our final section of the SMS Research Methods Interest Group Doctoral and Junior Faculty Consortium, where the focus is going to be on a subject, on new advances in panel models and identification. And there has been a host of recent developments in the last few years. Like really the economics and econometrics space is exploding with insights about what we've been doing in the past. And so it's really worthwhile to show up there. And that's it. I will see you all in 2 weeks. And thank you again to Sandeep and Andy for speaking. And of course for Sarah for helping to organize, and everybody who was here today. So thanks.
Thank you. Thank you for being.